Modified Alsever solution contains all the necessary nutrients and antibiotics for in vitro reagent red blood cell storage. After watching this video, the learner will be able to state the proper use of the modified Alsever solution in the immunohematology laboratory, describe the procedure for preparation and quality control, and discuss a validation protocol for red blood cell reagents preserved in the solution. Here is a list of the materials needed. An automatic magnetic stirrer is recommended, particularly when dissolving the antibiotics. To avoid contamination, it is important to use clean, preferably autoclaved flasks, stirrers, and spatulas, and always use aseptic technique while preparing the solution. As always, use appropriate personal protective equipment for the laboratory. Measure approximately 600 ml distilled water into a 1-liter flask. Each of the following are first measured and dissolved into the water: citric acid, dextrose, inosine, sodium chloride, trisodium citrate. Measure out each individual ingredient to the proper specifications, and they can be added together before added to the water. After the initial ingredients are dissolved, add chloramphenicol and neomycin sulfate. Mix well. Dilute to 1 liter with distilled water. And again, mix well. The antibiotics typically do not dissolve quickly. Therefore, an automated magnetic stirrer is helpful. For quality control of the reagent, test the osmolarity and the pH. The osmolarity should be between 330 milliosmoles per kilo and 350 milliosmoles per kilo. The pH should be between 6.6 and 7.0. If necessary, the pH can be adjusted by adding small amounts of sodium hydroxide, mixing well, and checking periodically. Be sure to wash your hands thoroughly before performing phlebotomy. Whole blood is drawn from a donor of the desired phenotype you wish to preserve in the solution. An EDTA tube is optimal for sample collection. Label the tube appropriately. The collected whole blood is centrifuged to separate the plasma from the packed cells. After centrifugation, carefully aliquot off the plasma or serum. Only the red cells are necessary. The red cells are then washed with either modified Alsever solution or normal saline. Add this back to the packed red cells, mix well, recap the tube, and centrifuge for 1 minute. After centrifugation, carefully aliquot off the supernate and repeat the wash steps 2 additional times or until the supernate is clear. A 2 to 5% volume per volume cell suspension is then made with the washed packed red blood cells in the modified Alsever solution. After adding the packed red blood cells to the modified Alsever solution, gently mix with a pipetter by pulsing up and down. I will give several examples of suspensions that are too heavy or too light. The 2 to 5% suspension can be visually checked against a manufacturer's prepared cell suspension to ensure it is neither too heavy nor too light. Once the 2 to 5% cell suspension has been made and is acceptable, label the vial And always keep stored at refrigerated temperatures while not in use. Keeping stored at refrigerated temperatures slows bacterial growth and breakdown of the red blood cells. If properly stored, this red blood cell reagent will remain viable for several weeks. An important part of a validation protocol is the daily inspection of the supernate for hemolysis or other evidence of cellular breakdown. It may be helpful to culture the reagent after several weeks to ensure sterility of the process. Antigen testing the blood on the first and last day of use and the comparison of the results is also helpful. Rh and Kell system antigens are integral to the RBC membrane, while Duffy antigens tend to elute during storage. Antigen testing could include Rh, Kell, and Duffy antigens. I hope you found this presentation helpful and may be able to implement some of the techniques shown in this video into your immunohematology laboratory.